Hello everyone, here we are again to discuss Chapter 7 Chemical Bonding, 7.3 Intermolecular Forces Part 2. In this part, I will explain about van der Waals forces and hydrogen bonding. Before we go details about intermolecular forces, it is important for you to know and understand about molecular shape and molecular polarity. Intermolecular forces are important to determine the physical properties of molecules such as boiling point, melting point, density, or vapor pressure. The stronger the intermolecular forces, shorthand as IMF, the higher the boiling or melting point. Okay, the picture here shows the intermolecular forces between hydrogen chloride molecules. Okay, the covalent bond in the hydrogen chloride molecule is a strong bond. So the bond is actually the intramolecular forces. And the interaction between HCl with another HCl molecule is called the intermolecular attraction, which is weaker compared to the covalent bond in the HCl molecule itself. So intermolecular forces is the attraction between molecules are not nearly as strong as the intramolecular attraction that holds compounds together. So the definition can be simplified as the attraction between molecules. There are three types of intermolecular forces, which are London forces, which is also known as dispersion forces, dipole-dipole interaction, also known as permanent dipole, and the last one is hydrogen bonding. Okay, let's look for the first forces, which is London forces or dispersion forces. So as you can see in the picture here, we have two molecules of hydrogen molecules, okay, molecule A and molecule B. Okay, in the ordinary state, the electron distribution of molecule hydrogen is even and no polarization occur. But at any instant moment, one of the molecule of hydrogen have an instantaneous dipole on atom A, and this instantaneous dipole will induce a dipole on atom B. Okay, when the two hydrogen molecules has an instance dipole, so the dipole attract one another, and this is what we call London forces. So basically, the London forces occur in all molecules, and it is even significant in nonpolar molecules. Attractive forces that arise as a result of temporary dipoles induced in atoms or molecules. So this is what we call London forces. And the London forces is the weakest force. However, the larger molecules will have a bigger or higher polarizability and will result in the stronger London forces. So as example, if we have hydrogen gas molecule and chlorine gas molecule, so basically the chlorine gas molecule have stronger London forces because the size of the chlorine molecule is bigger compared to hydrogen molecules. The second type of intermolecular forces is dipole-dipole forces. So dipole-dipole forces is actually the attraction between positively and negatively charged particles of different molecules. Okay, so the attractive force between polar molecules must be close to each other so that the opposite charge attract. Dipole-dipole forces increase with an increase in the polarity of the molecule. Okay, so this molecule exists only in polar molecule. So when the two polar molecules are nearby to each other, so the attraction will become significant and the dipole-dipole forces arise. Okay, the last one is hydrogen bonding. So hydrogen bonding is a special intermolecular forces. Okay, so as you can see, The example of hydrogen bonding here is in water molecule, in ammonia molecule, and in HF molecule. So in order for a molecule to have these forces, okay, it must contain nitrogen, oxygen, or fluorine atom that attach to the hydrogen. So we can define the hydrogen bonding as the electrostatic attraction between hydrogen atoms bonded to small, strongly electronegative atoms, which are nitrogen, oxygen, and fluorine, and the lone pair electron on these electronegative atoms of neighboring molecules. The basic requirement, as I mentioned earlier, is that the hydrogen atom must be bonded to fluorine, oxygen, or nitrogen with at least one lone pair. So in the short form, it is easier for you to memorize the hydrogen bond as handphone. H-F-O-N, handphone. Hydrogen bond is a strong force because hydrogen atom is very small atom and the nucleus is very exposed to the lone pair of the highly electronegative atom of oxygen, nitrogen, or fluorine. So, for example, in water molecule, the hydrogen atom of one water molecule is attracted to the lone pair of the oxygen atom of another water molecule. So the attraction between this small atom of hydrogen and the high electronegative of oxygen is called the hydrogen bonding. So as the conclusion, London forces and dipole forces are known as van der Waals forces. Intermolecular hydrogen bond, which is hydrogen bond formed between two molecules containing hydrogen atom bonded to F, O, or N atom. Dipole forces is stronger than London forces. Intermolecular hydrogen bond is stronger than van der Waals forces. So in diagram form, this is the comparison of relative strength of these forces. London forces weaker than dipole forces, weaker than hydrogen bonding. So that's all. Thanks and bye.